What is up, everyone? Hopefully you're really excited for this week's Moralis blueprint in which you're going to build a Web3 decentralized PayPal. We're going to write a full Solidity smart contract which mimics a payment service where you can send and request payments from your friends with your name and messages alongside your payments. Then we're going to deploy and verify the smart contract using Hardhat, and then use the Moralis Web3 API to interact with the smart contract, read data from it, your history of payments, the name you've set on the smart contract, and of course, information from the network like your native balance and that native balance in US dollar values. And then finally, we're going to build this beautiful front end to make it easy to interact with any data on this Web3 PayPal smart contract. So let's take a look at what this final product will look like. So we can request some payment. Let's request some payment from account 1 over here, which I've stored on my clipboard. Let's ask for lunch money. And go ahead, and there's only 5 Matic for lunch, so let's proceed to request. MetaMask pops up automatically. We confirm it's just sending this request to our smart contract. And now we can go ahead and disconnect the wallet and go to our account 1 over here, account 1, and connect our wallet. And you see over here, we have one open request. Let's go ahead and pay this request. We're sending a payment to Samantha, who we just sent the request from. The value is 5 Matic. And the message associated with this payment is lunch. So all this information is on the smart contract. We're happy with this. We proceed to pay. MetaMask pops up again. Ask us, do we want to send this 5 Matic to Samantha, but through our smart contract? Of course, you could set your own payment, take a little fee if you'd like to, then go ahead and confirm this. Confirm like so. And as it confirms, it should be appended to our table over here, and our one request should go away. Samantha has just received from us 5 Matic for lunch, and our balance went down. And as we disconnect our wallet, go ahead and check out Samantha's wallet, which was account 4 over here. Connect our wallet. We should have just received from J-Man over here 5 Matic for lunch, and our balance is slightly higher. Hopefully you're excited for this build. Now get stuck in and we'll build this in this Saturday's Moralis blueprint. Rightio, let's kick this Moralis project off by heading over to your favorite IDE. I use Visual Studio Code, but you're more than welcome to use whatever you prefer. I've opened up a directory called Web3 PayPal. It's an empty directory, and you should do the same. In this directory, we're going to use something called Hardhat to write our Solidity smart contract, then deploy it and verify it. And then whatever network we deploy it to, in our case, the Polygon Mumbai testnet, we can go check out that Explorer and test it out, testing out creating requests, paying requests, and viewing open requests and the history of transactions. And then once we know that all works, we'll use that smart contract to integrate it to our mobile app, and you can start playing around with actually using the app as a Web3 version of PayPal. So if this sounds good, let's head over to the terminal over here and install Hardhat by running npm i-d Hardhat. And after we've installed Hardhat, we can initialize a Hardhat project by running npx Hardhat, and this should create some files in your directory after you press enter 4 times. Like so. Now you see we have all these files. We have a contract, we have scripts to deploy our smart contract, etc., etc. But before we head in to these files, let's go ahead and install all the dependencies we'll need. So let's go npm i-d.env, then npm i-d @nomiclabs/hardhat-waffle. Great, and then you can just press the up arrow key and remove the waffle and do hardhat-ether scan. This will help us verify our smart contract eventually. And that should have you set to go, and you can jump over into the contracts folder, and there is a pre-created Solidity file called lock.sol. Well, let's open that up. And what you can do is remove all the files underneath the 4th line like so. And up over here at the top, we'll just define our license to be MIT. Now we're ready to hustle. We're using Pragma Solidity version 0.8.9. If you'd like to go with a higher version, that's fine, but 0.8.9 will be sufficient for this project. Let's save this and start working on this lock.sol file. Actually, rather than calling it lock.sol, let's go ahead and right-click, rename it to paypal.sol, just for better naming convention. And now let's go ahead and look at what we have to do in our contract. First, defining a contract is simple. You just write contract, the name of the contract, which in our case is PayPal, and then squiggly brackets. And all the logic of this contract will go inside these squiggly parentheses. Now let me paste in here as comments all that we need to add. like so. Let's close up the terminal so we can see a bit better. And let's go through what we're doing. Let's also close this down. We're first going to have to, for good convention, define the owner of the smart contract. So anyone who's curious of who actually deployed this contract will be able to see that, just to provide some transparency. If you decide to take a little cut of these transaction or whatever, you know who the owner of the smart contract is. Then next we'll create a struct and mapping for requests, transactions, and names. So these structs are definitions of what a request or a transaction consists in them. So I'll have, for example, the address of the requester, the name of the requester, the amount, the message, etc. And these mappings allow you to see for a specific address what requests have been requested, what structs have been added for any specific address, and so on and so forth. You'll see soon enough. Then we'll have to create our first function, adding a name to a wallet address. So of course, on the blockchain, everything mostly happens with your crypto wallet address. But if you're requesting money from friends, it'd be nice to have a name attached to your wallet address, so you can do that with a add name function. Then creating a request. So if you want to request money from a specific wallet or friend, we'll have to add that functionality. Then if someone has sent you a request, there has to be a function to allow you to pay that request. And then finally, when we're viewing our app, we want to see all our requests and our historical transactions. So we have functions for them as well, getting all requests sent to a specific user and getting all historic transactions for a specific user. So let's go ahead and start off with defining the owner of the smart contract. So how we do that is first by defining a public address variable. Let's add a little spacing over here so we know what we're doing. So we define the variable type, which is a crypto wallet address. We make it public and we call it the owner. Now there is a function called a constructor, which is run on each deployment of the smart contract. So essentially only once. And within this constructor function, we can pass any arguments, but we won't pass any arguments because some user has to actually deploy the smart contract, or whoever is calling the function. That is referred to as the message sender. So we can set the owner variable to be the message sender in the constructor function. And that allows us to only call this owner variable once in the total history of the smart contract and set it to whoever deploys the smart contract. And now anyone can check the deployer of the smart contract. So that is our first step checked, like so. Nice little check mark over there. Now let's go over here and create the struct and mapping for requests and transactions and a name. So I feel like I can best explain to you what a struct is by explaining a live sample of one. So over here, we have a struct for a request. So essentially, it's like an object type defining what the object consists of. So this request object consists of 4 variables: a address, which is the requester, whoever the requester of the payment is, a uint256, so an integer of the amount they are requesting. So this will most likely be in the native currency, which is Matic. And then we have a string, which has the message. So for example, if Bob the Builder is asking for some bricks, he'll write bricks in this message. And then the string for the name of the user, and this will be received from the associated address. So if the address has added a name, as we said, add a name to a wallet address, that's the next step, then we'll add to these structs the name of that wallet address. So essentially, this is just a definition of what a request looks like in our smart contract. Now let's do the same thing for a transaction, and let's call this send receive. So because a transaction can be a receiving of some payment or actually sending of some payment, we have to first define in a string the action. So whether you're receiving or sending out money, then again, the amount that was received or sent out, the message that went along with that transaction, and then the address of the other party involved in the transaction, and the name, if there is one, added to that wallet address as well, stored as a string. And of course, with the mapping, you'll know the user's own address, so that's why you don't have to add that to this send receive struct, which includes a transaction. Now finally, for a name, let's add that. So a username over here consists of 2 variables. It is a string with the name of the user, and then a Boolean whether they actually have a name, because we'll create a mapping with all possible wallet addresses, and then that mapping will point to a username struct, and we can check quickly if they have set a name and what the name is. But if there isn't a name, the Boolean will be preset to false, so we can quickly see whether a user has set a name for their wallet address. So that is our structs created. But next, let's create the mappings, which map wallet addresses to these different structs. As this is relatively straightforward, after you get the hang of it, I'll just paste all the 3 mappings over here that we have, like so. So we have three mappings. The names are over here. So we have the names, requests, and history. And what these mappings actually do is allow within their smart contract, because we haven't set them to public, this would allow anyone to read them. But with not having public over there, these are only readable by our smart contract. And essentially, we just have to call, say, names, and then any wallet address like so, and that would give us a username struct. And by default, the string would be empty and the Boolean would be false. So now calling any address in this names mapping would give a empty string and a false Boolean. Same thing for requests. You just change the names to requests, and this would return to you for any address an array of request structs. So because you could have multiple requests, you'll have multiple of these request structs in this request mapping for a wallet address. So whenever we create a request, we add a request to that address in this mapping. So to follow this format, same thing, after a request is paid, then that will be removed from this mapping. So this gives you a little bit of an understanding about what a mapping is. You'll see them in use here later on as we create our functions, but that is the quick rundown. And we can move on to creating our first function, adding a name to a wallet address. Rightio, so let's scroll down so we have some real estate to work with, and let's paste what a function looks like in Solidity. So we declare a function, we give it a name, add name, and then what parameters it takes as arguments. So we get a string variable, we store it in memory. So this just means we store it for the execution of this function, and we call it underscore name. Then we set it as a public function so anyone can call it after the smart contract is deployed. And within the squiggly brackets, we write our functionality. And let's paste our functionality over here, like so. So let's go look at the first line over here. What we're doing over here is we're creating a struct, a username struct. We're using storage because storage means that we're going to save this to the smart contract, and we're giving it a temporary name, new username. And where we store this struct is in the names mapping for the message sender. So whoever calls this function, they're changing their own name. So we're changing their name in the mapping over here. And for this new username struct, we set the name to whatever was declared as the argument in the function call, and then we set the hasName Boolean to true. So now whenever someone checks whether this wallet address who's called this function has a name, that'll be true, and then we can see what the string in their name is, and we'll display that eventually in our app for someone to pay a request to, or in your historical transactions who you received money from. So that is how simple it is to create a function, a public function callable by anyone, to a Solidity smart contract. And now we can go on to a more complicated one, creating a request. So over here, like we did with creating a name or adding a name, let's create the function where we can create a request. We call the function create a request, as you would imagine, and then we provide three parameters: the address of the user we want to make the request to, an integer amount of how much we want to request, and then a message to go alongside the request so the user who received the request knows what they are paying for. And now again, within the squiggly brackets, we can write the functionality of this create request function. And here we have it. So we create a request struct. So as you see, the request struct has the requester, the amount, message, and a name. And we store it temporarily in a variable called new request. Now, for the new request, we set ourselves, the function caller, as the requester. So this will allow the person who receives the request to send the funds to the correct address. Then we provide the amount we set in the argument call. And then the message we also set in the argument call. Now, to figure out if this wallet address who's sending the create request has a name, we can write a little conditional over here. So we check the names mapping for the message sender, and we check the Boolean, whether they have set a name for themselves. If they have, then we can set the name to be that name that's set in the names mapping. But if they don't have a name set, then it'll just be set as an empty string, and no name will be attached to this request struct. And then finally, because the requests mapping is an array of request structs, I know I'm saying request a lot, but hopefully you're following. So what we do is we get the request for the user that we're sending the request to, and then we push this new request struct into that array of requests. So hopefully that makes sense to you, and that is how we create a request with a specified amount and message attached to it. So let's save that and now go on to figure out how we pay a request. So now after we've created a request, now the person who receives the request, how would they go ahead and pay that request? So as we've done a couple of times now, let's create a new function. And this is called pay request, as you might imagine. Again, good naming conventions is always good. It only takes one argument as parameters, and it's a integer for the request. So because we have a request mapping, we need to know which request in this array, so the index of the request we want to pay. That is the only parameter for this function. And you might notice that it's not only a public function, it is a payable function because we will have to make the payment to whoever has requested that payment. Now for the functionality of this function, let's paste that in here, voila, and scroll down a little bit so we see what's going on. Let's talk through this line by line. So first you see we have a require statement. What a require statement is, it checks the statement, and then whether this passes, it continues with the rest of the functionality, but if this condition doesn't pass, the function is reverted with this message. So first we require that the request index is actually within the length of the requests array for the message sender. So whoever's trying to pay one of their requests, we have to check that the request they're paying actually exists. Now, if it does, we create a couple of temporary variables. We create a request array and call it my requests. So what we do is we get our own requests from the request mapping, and then for the specific request we're interested in, we get that as well. So a request struct, and we call that the payable request. So we look into our my requests array and call the index that we're trying to pay. Now we can get the amount we need to pay. So we get the payable request amount. So this is stored in the struct, and we multiply it by the decimals. So a 1 and 18 zeros. So this turns the weight amount into actual native currency matic. And then we have another require statement saying that the message value, so we've used message sender, which gives the address of who's calling the function, but we also have the parameter of how much currency you send with that transaction. So the currency you send with the transaction has to be the same as the to pay amount. So we know that we have enough funds to pay the whole request we're trying to pay. And if it's not the same, we revert with an error message, pay correct amount. And now here is a payable function. So what this does, it actually only takes the requester from our payable request struct, and it transfers the message value to that account. And then finally, what we do is now we have paid this request, so we can remove it. So we do this little nifty thing. We take the last request from our my request array and we swap it with the request we already paid. And then we just pop the last request in the my request array, effectively removing the request we already paid. Now, this is all in good, but there's always a but. We haven't added to our transactions. And now with this request removed, there's no way we could check out our transactions that we paid it. So this means we have to add a functionality where we can add to our history mapping that we have paid this transaction, and for whoever receives it, they have received the funds. So that's what add history function does. Let's add it below over here, like so. So add history function, it takes a lot of parameters. It takes the sender, the receiver, the amount that was sent, and the message that went alongside the payment. But you'll notice this is a private function. So what this means, it's only callable within the smart contract. So we'll put a little function call within this pay request function that allows us to call the add history. This just allows us to avoid anyone in the public of calling this function and adding transactions that didn't actually occur. And now for the functionality, we again add a temporary variable, which is a send receive struct. So a send receive struct, as you remember over here, takes an action, the amount that was sent, the message that went alongside the payment, and the other party's address and name. So what we do is very similar to what we've done before. For the new send, we add an action of negative because the user is losing funds. So that's why the string is a negative sign. The amount we passed in as an argument, the message we passed in as an argument, the receiver address we passed in as an argument, and then the same thing, checking if the receiver address has a name in the names mapping. We take that name and set it as the other party name, otherwise we leave it as an empty string. And then we get the history mapping, get the sender address, and push this new send struct into that mapping. But of course, there's always two parties in a transaction. We have to add a new receive as well, but it's the exact same format as this, like so. So receiving money, of course, the action is a plus sign. You'll be receiving more funds, the same amount, same message, but the other party address in this case will be the sender, and we're pushing it to the receiver's history mapping. How cool is that? And that is the add history function, which we have to call before we pop the request from our requests so that we know that that transaction is paid. So we add a function called to add history over here, like so, and we set the sender of this payment request function call as the sender address. We get the requester from the my request struct, the amount, and the message from that same struct as well. And that has us all set. And we have two functions left to create. We have to get all the requests that a user has, and then get all the transactions a user has been a part of. So when a payment has been paid or payment has been received, these transactions will have to be able to see for any user. So that is what's left. And then we're ready to rock and go test this smart contract out. But now still focusing on getting our requests and our historical transactions. Let's go back and check out our mapping. So for example, for our requests, if we were to just return the response for our requests for any specific address, we would get an array of structs. Now, structs are a Solidity type, which would be very hard to read when we're, for example, reading in a Node.js application or in our React Native application that we're going to make. So what we'll have to do is we'll have to map through all the structs that are within our requests array and get the individual types as an array from there. So we'll get all the addresses that have requested payment from a specific address, and we'll get an array of all the amounts, an array of all the messages, an array of all the names, and then we'll post-process this in our client side. So let's actually write this out to make more sense of what I just babbled on about. So creating our function over here, like so, get my requests. It takes any user that you want all the requests that a user has. So most likely you'll ask for your own requests. And what it returns, so this is a public function that returns something, and what it returns is an array of addresses, an array of integers, which will be the amounts, and two arrays of strings, one for the messages and one for the names of the requesters. And now what we have to do is write the functionality to loop through our request array and fill out these arrays so we can return them. So that is done like so. We create a couple of temporary arrays, one for the addresses, one for the amounts, one for the messages, and one for the names. And what we do here is we create a new array and we define the length by getting from our requests mapping for the user. We passed in as the argument the length of the requests array, and that defines the length of the new arrays that we just created. And then we just loop around starting from the first index of our requests array, and for all the requests in the array, we get a single request, my request, and then we get the requester amount, message, and name, and we just push them into that index in these new arrays we've created, and at the end we return them. So in this way we have a returned array of addresses, returned array of amounts, returned array of messages, returned array of names, which we can then post-process into a nice object having all the requests in one. How cool is that? And then finally, we do the same thing for our history or historical transactions. And that is very simple. We just get an array of send receive structs for a specific user and return them. So get my history is the function name. And we actually need to do this exact same thing for get my name so we can get the name of any specific user. But in this case, as the names mapping only has username structs in it, not an array of username structs, we pass a username struct as the return statement. And that is basically it. We've checked off all our comments that we set out at the start. It's a big smart contract over here, but now we're ready to start deploying it. So let's go ahead and save this smart contract. Let's remove this check mark just in case. I don't know if it'll make a difference when compiling it. So now open up the file directory and jump into the scripts folder and the deploy.js file. Rightio, so this is the script the Hardhat will use to deploy the smart contract we just created over here, paypal.sol, and it's pre-populated with stuff for the sample project that we created with npx space Hardhat. So we can go ahead and remove, for example, these comments and remove everything above the first declaration of a lock. And then for the console log down here, let's just say PayPal deployed to, and the address is deployed to. And over here where we deploy it, this was where the constructor arguments would go. And we don't have any constructor arguments for our contract, so we can save that. Now, just to make it look prettier and not have these locks, let's open up the Finder, command find, and find all the locks and put it into case sensitive mode. And that this way we can change them all to PayPal, like so, and do the same thing for lowercase locks and change them to lowercase PayPal, like so. And that is all you need to do for your deployment script. And then finally, we can move on to the hardhat.config.js file, where we will declare all the information required to deploy and verify our contract. Right, so first off, the require statements, we can get rid of what we have over here and require the dependencies we installed at the start of the video: Nomic Labs Hardhat Waffle, Nomic Labs Hardhat Etherscan, and .env from .env, like so. Then we will configure .env, like so. So we will be creating a .env file where we store all our private keys and API keys, etc., etc. And now for our module exports, this is where we provide the details for the network we're connecting to and our Etherscan API keys so we can verify our smart contract. So first of all, networks is where the details about the network we're deploying to will go. And then Etherscan is where the details for our Etherscan API key will go. In the networks object, we still have to provide the network we're deploying to, which will be the Mumbai testnet for Polygon. And in here, we have to provide an RPC URL and the account that we'll use to deploy the smart contract. So where we'll get all this information, of course, in the Etherscan, we'll also have to have the API key we are going to be using. So let's create a .env file where we can get all these variables we need to provide in our module exports. So hardhat config, we've pressed that, so we can just create a new file, call it .env. And here you actually use a actual dot, not just type out dot. And in here, let's define the variables we need. So we need a RPC URL for a node on the Polygon Mumbai testnet. Then your private key for your wallet on Mumbai, you need that to be able to deploy the smart contract and use the funds to deploy. And then finally, the API key for the Polygon Mumbai Block Explorer, so you can verify your contract and we can go test it out. So let's start off with the API key because that's the simplest one. So open up your browser. So here I have Chrome open and a tab on polygonscan.com. I've logged in already, so we can go check out my profile. But if you haven't created an account, you can create an account very simply and for free. Then go to API keys, and here you see I already have the key, but you can add a new key from over here. Just call it PayPal. And now we have a new API key. Of course, do go create your own because I will be deleting these before this video comes out. Then back into Visual Studio Code, and then just paste your API key in here. Now for your private key, let's go back to our browser, open up MetaMask or whatever wallet you use, and then let's go to account 1. We'll use that because it has the most Testmatic. If you don't have Testmatic, you can go to Polygon Faucet, which will give you free Matic if you paste your wallet address over there. But essentially, you have to go over here, 3 dots, account details, export private key, and after you paste your MetaMask password, you'll get your private key, and then you can go ahead and paste that in over there. I won't, of course, do that here. Even though it is Testmatic, it's always good practices to keep your private keys to yourself. And then for RPC node URL, you could use whatever you like for this. There's numerous different partners where you can get a node RPC URL like Chainstack, Alchemy, Infura, and paste that in there. I'll save this over here and then post-processing add my own details over here, and then go back to hardhat.config file. Go ahead and paste the variables in here, process.env.polygonmumbai for the URL, then for the accounts, process.env.private key, and then for the API key, process.env.api key. Save that, and would you know it, I believe now we're ready to start deploying and verifying our smart contract. So again, you can close up this file directory, open up your terminal over here, let's clear our terminal, and start deploying our smart contract. First things first, let's run npx hardhat clean to clean our directory up. Oh, looks like we got an error. There's some new dependencies we need to install. So I'll add these into the Academy content so you can add these dependencies as well. But let me just paste these in here and install them. All right, that took a while, but now I'm back. So let's try it again. npx hardhat clean. That's all right. So npx hardhat compile next. Compiled one Solidity file successfully. Awesome. And now for the golden ticket, let's deploy our smart contract. We have to use this deploy script in our scripts folder. So let's go ahead and do npx hardhat run scripts / deploy.js. And we also have to add 2 dashes, network, and then Mumbai to define that we want to deploy it on the Mumbai testnet. Well, wouldn't you look at that? PayPal deployed to, and then we get an address where it was deployed. How cool is that? We've deployed your smart contract. Now, final thing, you'll also want to verify it so we can see it on the block explorer and play with the code. So let's run npx hardhat verify, then your contract over here, and then again, -- network, Mumbai, run that. Okay, seems like we did this way too quickly. It hasn't propagated to the backend yet, but let's try and do this very shortly again. We can actually go check out Polygon scan over here, change to the testnet, and check out our contract like so. Look at this, contract creation 1 minute ago. How cool is that? So let's go ahead and try that again. npx hardhat verify, and now the contract was successfully submitted for verification for the Mumbai Test Explorer, and now we're just waiting for the verification results. This might take a while as well, so I'll jump back to you when it is done. Awesome, so that happened very quickly. Successfully verified contract PayPal to Etherscan, but actually means Polygon scan because we defined it as the Mumbai testnet. And you can see your contract over here, but we already have it open on Google Chrome over here. Our contract symbol doesn't have a green check mark yet, but if we refresh, look at that, contract check mark, and we have our Solidity PayPal smart contract over here for the whole world to see. And we have our contract API generated over here, and we can actually start reading the contract functions that we created, get my history, get my requests, and we see the owner, and we can start writing contract functions after we connect to Web3. We can add a name, create a request, pay a request, and so on and so forth. So now let's go ahead and test this out over here on Polygon Testnet Explorer, and then go ahead and integrate the smart contract into our mobile application. And then you're finished off. How cool. Give yourself a big tap on your back if you made it this far. You've actually deployed and verified a actual fully fledged smart contract. All right, so before I showcase to you the functionality of the smart contract on video, I tested it out myself just to make sure it works. So for transparency over here, you see that there's a few transactions that happened on this smart contract already, and it works beautifully, so we can test it out ourselves. So what we can do is first of all, read the contract. I set a name for this account over here, account 0xF03. So if we copy that over and get my name, let's paste that in here like so, and query. And now we should get the name, which I set to Samantha, and the Boolean for whether this account has a name has been set to true. Very cool, very cool. So then again, we can go ahead and get my history. So I sent 1 request and paid 1 request. So I'll put my address in here again, like so, query this, and look at this. We get 2 arrays, one where I sent 1 Matic, 4 bricks to this account, and this account has a name of Bob Builder. And one time I received 8 Matic for movie snacks from the same account, Bob Builder. And we can go ahead and check if we have any requests at the moment. Let's go ahead and paste our address here once more, query this, and we get an empty set of arrays, meaning that we don't have any requests. But now I'll show you how we can make a request to this account and then go ahead and pay it. So let's go ahead and write a contract. Let's go ahead and disconnect our account, disconnect from here, and change to, for example, account 1 over here, connect to Web3, MetaMask, and we're connecting account 1, next, connect. Beautiful, and of course I'll show you how to do this on your React front end as well. So now this account doesn't have a name yet. Let's just make sure that we're connected, 0x42, which is our account 1. Let's add a name, let's say Jman. That's me, let's go ahead and write that. MetaMask pops up, asks us, do we want to give ourselves a name on this PayPal smart contract? We confirm. And now we wait for that to go through, adding a name, and excellent, that went through. So now we have a name on this smart contract. So when we send requests people will know who the request is coming from. So let's do that next. Go ahead and create a request over here. Let's send it to account 4, which we have copied on our clipboard, like so, 0xf0. And as for the amount, let's send a request for 3 Matic. And as the message, let's say Coca-Cola. I really like Coca-Cola. That's an expensive Coca-Cola 3 Matic, but let's go ahead and write that. And now MetaMask pops up again, asks us, do we want to send this request? We say confirm, and now that is pending. And beautiful, once again, the contract interaction went through. So now what we can do is go ahead and read the contract, and we can go ahead and get my requests again for this account we just sent the request to, query this. And look at this, now we have 0x4D2, which is my account 1, for 3 Matic with a message of Coca-Cola, and J-Man has sent me a request to pay this. So what we can do is go ahead and write contract. Let's refresh this page. Let's go ahead into MetaMask, disconnect our account 1, disconnect this account, and jump over to account 4 over here, and go ahead and connect to Web3. MetaMask. Next, connect. Press connect again, MetaMask, and OK. And now we're connected with 0xf0, and we can go ahead and pay my request. So the payable amount will be 3 Matic, and the request is this 0f index, and let's go ahead and write that. So our first index from all our requests, which we saw we have 1, we're going to go ahead and pay that for 3 Matic. We're going to send it to the smart contract, and the smart contract is going to send it to our account 1. So account 1 should go ahead and have 20 Matic, and account 4 over here should go ahead and have 5 Matic. Let's confirm this. Open up MetaMask just to see everything worked. So as this contract interaction goes through, we should be reduced to 5 Matic over here. And just like that, 8 Matic turned into 5 Matic. The contract interaction went through. We can check out our account 1 here now has 20 Matic, not 17. So they got the 17 Matic. And on our smart contract, we can actually read it, make sure that my history with my account has 3 transactions. Query this, and look at this. We just sent 3 Matic for Coca-Cola to J-Man. So our PayPal smart contract is working beautifully. We can get it to work here on the Polygon scan block explorer, but next step is to create a backend so we can query this smart contract with Moralis in order to get all the same details and then hook that up with a beautiful React front end so this process is even smoother. Let's go ahead and do that. All right, now moving on to our front end and back end portions of the build. Here I have Visual Studio Code open, and I've cloned this repository PayPal starter from GitHub. The link to this repository will be in the link description where you can get it. Of course, it'll have the smart contract for you, which we created at the start of the video for your reference. A beautiful front end, which will get you off to a flying start with all the CSS included. You can play around with that. But then, of course, a Node.js backend powered by Express with a simple template to get you off to a flying start. And this is where we'll start our build here in VS Code. So get ready and let's start building this. First thing first, of course, you have to have a .env file where you'll have your Moralis API key. And you can see over here, we're bringing in .env like so, require .env config, and that gives us access to the environment variables Moralis_key. So you have to set that in your environment variables. Where you can get your Moralis key is going to Google Chrome, then go ahead and locate moralis.io. It'll bring you to a website like this. You can go ahead and check out the pricing for the different plans. There is a generous free plan, but for more serious projects, if you're looking to build the next unicorn Web3 company, we have the Pro, Business, and Enterprise plans for very reasonable monthly pricing. And of course, you get a discount if you go for an annual rate. But what you can do is start for free over the top, or if you already have an account, just log into your account. This will direct you to the Moralis admin dashboard, and over here in the submenu Web3 APIs, you can copy your API key, which you'll paste in your .env environment variables. So that's got us started, and the package.json has all the dependencies for this project. So opening up your terminal, let's go ahead and make sure we're in the backend folder, cd backend. And after that, you can go ahead and run npm I to install all the dependencies for this backend project. Like so, we're ready to go. And now we can close the terminal for a bit. And here, start off with this endpoint, get name and balance. So we'll have this one endpoint, which is a get request, in which we'll query the Moralis API for the read-only functions on the smart contract. So the Moralis API will allow you to use these functions, get my requests, get my name, get my history, to make sure to know the status on the Web3 PayPal smart contract for a currently logged in user on our front end when we go ahead and build that. So now let's go ahead and start off in here. And first thing first is when we send a GET request to this get name and balance endpoint, we'll also send a query parameter called user address. And this will allow us to call the functions on the smart contract to get the history and name for the address that we queried. And now, first, we'll create that function to get the name of this user that we've sent to this endpoint. So let me just paste in the Moralis query over here. So we'll get a response. We'll be awaiting Moralis, the EVM API, utils method, and run contract function endpoint. And we'll have to pass a few parameters in here, like so. So the chain, of course, is the hex index for the Mumbai testnet. And the address is the smart contract address. The function name is getMyName as we set in our smart contract. Then we have to have a ABI. The ABI is already set in the template for this backend, but if you're interested, it's here in the ABI JSON file. This is the ABI, the application binary interface for the smart contract. If you want to check it out yourself, you can always go to the smart contract over here, read the code, and scrolling to the bottom, this is the contract API where you can copy it from here. So that's where we get the ABI. And then this getMyName function, as we know here in the smart contract block explorer as well, getMyName takes one parameter, which is _user, which is an address. So we pass that in the object over here, params _user, which will be set to the user address that is sent to this endpoint. And now what we do is go ahead and get the raw format of this response and save that to a variable called JSON response, which will be the response of this endpoint. Like so. So our JSON response will be the response's raw format. And then let's just create a variable over in here, as we'll have other responses for the other contract functions as well. So our JSON response, the name key will be our JSON response name. And then let's just pass it over here, JSON response, like so. And now you're ready to actually test this out. We can actually go ahead and get the name for any user address that has set a name on the Web3 PayPal smart contract. So if we open up our terminal, go ahead and run node index.js. I think I typed KS. Let's go ahead and do JS like so. And now we're listening for API calls. We can go over into Google Chrome and make a simple GET request to get name and balance. We can do it here in the tab where we have our Moralis admin dashboard, like so. So localhost 3001 is the port we set this backend to run on. Get name and balance is the endpoint. And as the query parameter, we set a user address, which is equal to our account one. We set the name for JMan. So if we send over this GET request, look at that, we get a response, a name array with JMan as the first element and true as we have set a name, so the Boolean is set to true. So this is very awesome. We can call a smart contract directly from our Node.js backend over here with Moralis. But now we have all the other information as well. We have to get the balance of this user, so we know in our front end how much Matic we currently have and the US dollar value of that, of course. And then, of course, getting history of transactions and the current requests for this user. So let's go ahead and implement those after our JSON response name over here. Let's go ahead and fly through these because they are very similar to this first request over here to Moralis. All right, so for getting the native balance of the user, we can use another Moralis endpoint like so. Get native balance from the EVM API balance method. Again, we have to pass the chain, so Moralis Mumbai testnet, and the user's address we send to this endpoint. And this raw response will give us, of course, the user's balance. And it'll be set in the balance key like so. So what we can do is divide by the decimals. Matic, of course, has 18 decimals, so we divide by that and we set it to 2 decimal points so it presents nicely when we finally add it into our front end. So now let's add that to our JSON response over here, balance like so. And then, of course, as we have the native balance, users usually want to see the dollar balance of the cryptocurrency balance. So let's go ahead and use another Moralis endpoint, get token price. And as we're on the Mumbai testnet, we'll actually use the Matic tokens on the Ethereum network to go ahead and get the Matic price on the Ethereum network. And we'll just use that. Of course, on the live production environment, you'd be on Ethereum network or Matic network anyways. So what we can do is simply create a third response where we await Moralis EVM API, the token method, to get the token price. And here we set the Matic token on the Ethereum network. You can check that out yourself if you'd like. And then we can go ahead and format that nicely into the dollar amount, like so. So our JSON response for dollars will be our third response over here, the raw format, the USD price key. And as this is the USD price for one token, we multiply that by our native balance to get our USD dollar balance for this wallet in the native cryptocurrency Matic, testnet Matic. And now let's go ahead and add the dollars over in here as well. Dollars will be equal to JSON response dollars. And now let's go ahead and try this out. Let's open up our terminal. Let's go ahead and run Ctrl+C, clear the terminal, and go ahead and run this again, nodeindex.js. And now as we go to Google Chrome where we made our request, as we refresh this, we should get two other keys, our balance and dollars. Let's go ahead and refresh. And look at that, we get that exactly. The balance is 20.97 and the US dollar balance is 23.52, as one Matic is currently just above $1. And we can confirm that over here in MetaMask. We have our account 20.97 and the USD price slightly different, 23.47. Of course, depending on the rate that is used, but very, very similar over here. So now we already have interaction with the smart contract to get the name of the user using the Web3 PayPal smart contract. We have their balance and their dollar balance. Now, last things to do is call the smart contract again to get the history of the user and the current request if they have any request payable. So let's go ahead and jump back into Visual Studio Code over here and go ahead and implement that. Close down the terminal. Alrighty-o. So after we've got the dollar balance, now let's use this exact same format, run contract functions, read-only functions, but this time get my history over in here. It'll be the exact same query in all other parts. So let's go ahead and paste it over here. Our fourth response, we're awaiting Moralis EVM API, the utils method to run contract function, and using the exact same thing, our smart contract, Mumbai testnet, the function name is get my history, and the parameters it takes is exactly the same. Now, what will be interesting is to see what the response for this fourth response is. Let's go ahead and add that over in here. History, like so. And what we'll do is do the fourth response for response and the raw format. Let's first of all see how it looks. So save that. Let's go ahead and restart our backend. Go ahead and run Ctrl+C nodeindex.js. And now go ahead and refresh Google Chrome. Go to our request over here, refresh this and see what we get. And look at that, we get our history. We had that one request we sent to account 4, 0x4FO, which the account name was Samantha, and we asked for 3 Matic tokens for our Coca-Cola. But it is set in an array format, which will be difficult for our front-end table to actually read. So what we'll do is change this, give all these variables a key and change this array to an object. This way, when we go ahead and do our front end, it'll be easier to pass this array of objects with different keys to our table and then go ahead and render a table with all the history. So let's go ahead and do that. Jump into Visual Studio Code, create a function over here at the top, which converts an array to objects. Like so, simple as that. Convert array to objects. So we pass an array and then we'll map to the array, which has arrays within it. And for each array, we'll give a key property for the object, the type, which will be the array's first element, the amount will be the array's second element, the message is the third element, and so on and so forth. And this was all passed over here. We have 1, 2, 3, 4, 5 elements in each array. So if we check out over here, we have 1, 2, 3, 4, 5 elements, and then an extra key, which will help identify each row in our table when we go to do our front end. So we'll use this convert array to objects function as we scroll down over here. But before we do that, I feel like I missed one crucial bit over here in the convert array to objects function. We have to return, of course, the data array over here, and we'll do it in reverse order so we get the latest transaction at the top. So now that's beautiful. Let's use this convert array to objects function over here for our for response. So just for convenience, like we have for these others, let's go ahead and create a variable JSON response history where we use the convert array to objects function. We pass the for response raw over in there, and over in here, we'll just use the JSON response history like so. Final thing to do is now do the requests, and that is super simple. It's exactly the same thing. So we can copy that. Let's paste it over in here, get my requests, and this will be our 5 response, our 5th response, and this is only the raw format of this response will be suffice for us, so we can simply get the JSON response of the requests by getting the raw format of our 5th response from the Moralis API, and then over in here create a requests key, requests, and pass in the JSON response request. Now finally, now our backend is ready. We have this one endpoint, get name and balance, which gets us all the details we need for a user who is using our Web3 PayPal. So let's go ahead and open this up, restart our backend one more time, node index.js, like so. As we close this down, now we should have a fully functioning backend endpoint over here. And look at that, that looks beautiful, beautiful. We have our name, JMan, our balance in the native balance, balance in dollars, our history with an array of objects, and here are our requests. This account currently doesn't have any requests, but we can actually make a request and you'll see how it displays over here in the request. So if we open up our smart contract, let's go ahead and write into our smart contract, connect our, for example, account 4. Let's switch to account 4 over here. Connect this, connect to Web3, MetaMask. Okay, so we're connected with account 4. Let's create a request. Over in here, the user address will be our account 1, which we can copy over from here, paste that in here, like so. Let's set an amount of, for example, 5 matic, and the message, what we'll say is cookies and milk. So we had some cookies and milk with account 1, and now we're requesting 5 matic for the cookies and milk that they cost. Let's write this to the smart contract. MetaMask pops up, we confirm, and now account 1 should have a new request as it goes through over here. Like so, the contract interaction went through. So now as we go back to our get request, let's refresh this. Look at this. Now we have one request over here. In the first element, we get who the request was from, their address. In the second object, we get an array of all the prices that were requested. The third key will have the message associated with it, and the final key will have the requester, which in this case was Samantha. Samantha has set their name on the smart contract. Beautiful, beautiful, beautiful. So now with all this data, we can hook up our front end with our backend. So whenever a user logs in, we can send the user's address to our backend and get their status on the Web3 PayPal smart contract. How sweet is that? So we can actually move on to that. Jumping out into Visual Studio Code, let's go ahead and open up our terminal. Let's go ahead and create a new instance of our terminal and cd into our front end folder, cd front end, like so. Here in our code editor, we can close down our index.js file and our backend here in our file structure and jump into front end over here. And here you see, if we opened up the source folder in the index.js file, we see we have a very simple React app, which is hooked up with WAGMI. So this will be our Web3 library that allows us to connect our wallet. And we're using the Polygon Mumbai network, which our smart contract is on. And then if we jump into app.js over here, this is our main file. We're using the ant-design design library to make everything look sweet and nice for us. And then we have a couple of components, which you'll see we have the current balance. We can have the request and pay component, which allow us to make request and pay request. Then we'll have the account details, which will have the name of the user on the Web3 PayPal smart contract and their native balance. And then we have the recent activity component, which will of course have a table of the history of the user on the Web3 PayPal smart contract. So here in front end folder, let's go ahead and install all the dependencies, npm I. With all those installed, we can go ahead and run npm run start, which will start up our React app on localhost 3000. And voila, look at this. So we've set up the front end for this build already, so we don't have to focus on any of these components creating the CSS styling. Of course, all the CSS styling is in the index.css file and app.css file if you want to see how we've set it up. But we'll focus on the Web3 functionality for this project. So we're going to go ahead and look at how we can connect our wallet, get our details from our backend and populate them to these hard-coded values that we have currently. So the basic things we'll do is we'll connect our wallet using the WAGMI Web3 library. Then for For the US dollar balance, we've already checked how we can do this. We've created a backend endpoint, which we can call to get this value. Then, of course, we can get our account details. We can get the address from our WogMe login, but then we can get the name used on the Web3 PayPal smart contract from our backend as well, and the native Matic tokens we can get from our backend call as well as my history, which is depicted very beautifully over here in a table. Now, finally, the hardest bit of this build will be the pay and request functionality. So this will allow you, as you press it, to create a new request. So we will have to call these functions on these write functions on the smart contract to create a request. And then for paying a request, we'll have to get the current requests from a user and pay them in order that they've come. So as you pay this should trigger a function to pay your most recent request over here and set the payable amount and the request ID so you can go ahead and pay any request that users have sent to you. So with that said, now let's go ahead and jump in to first connecting our wallet to this build. Let's go ahead and do that. Jump into Visual Studio Code over here. Close down our terminal for now. And here in our app.js file is where we'll do it. We'll connect our wallet. So let's go close down the file structure and start over in here. Alrighty-o. So the imports for connecting your wallet will come from WogMe over here. Let's paste them in. So we'll use the use connect hook, use account hook, and use disconnect hook, and then the MetaMask connector. So we can use MetaMask to connect to this React app. Then let's go ahead and destruct what we need from these hooks, like so. So the use account hook will get us a Boolean of whether we're connected currently or not, and a address. So the address of the user who's connected to the site. We can use this address to send a request to our backend then. Then the use disconnect hook will give us a function to disconnect our account from the website. And then the use connect hook will give us a function to connect our wallet and pop up MetaMask to connect our wallet to the React app. Beautiful. So now for the disconnecting bit, we'll actually create a function where we call it disconnect and set to null, because we'll have state variables over here which store the currently logged in users' balance, history, requests. So as a user disconnects, while they disconnect, we also will set all those state variables to null later on in the video. But now, with all this set, what we can do is conditionally render the page. So now when a user is not connected, we shouldn't get all of this. We should only get the MPay over here in the top corner and the connect wallet button. And as we connect to the wallet, we should get all this information, and this connect wallet button should change to a disconnect button. So let's go ahead and implement that. Visual Studio Code over here. Let's go ahead and first do it for our menu options over here. These do not have to be visible when you're not connected. So we'll use the is connected Boolean. And if we are connected, what we can do is present them. So let's go ahead and close the squiggly bracket over in here. So now if we're not connected, we shouldn't see the top header. So let's go ahead and save that. Look at the page. Look at that, those were removed. Now this connect wallet button should also have the functionality to connect your wallet. So let's go ahead and do that next. Here we have our connect wallet button over here. Let's go ahead and add the functionality to use our connect function to connect our wallet. So on click of this button, we should be able to call the connect function. So let's save that. And what we'll also do is create a conditional for this. So if we are connected, is connected, what we're going to do, let's just add a question mark and a semicolon. So we'll have two things we render. So this button will be only rendered if we are not connected. And if we are connected, we'll have a disconnect button added in there like so. So it is a button. The only thing is that it'll have a disconnect wallet text. And when we click it, we call the disconnect and null function, which currently just disconnects your wallet. So let's go ahead and save that. And we can actually go and test this out. Let's go ahead and format this as well. Option Shift F. So everything looks beautiful and nice. Save that. Google Chrome. So still we need to conditionally render the page. But as we connect our wallet, as we're not connected, it opens up MetaMask for us. Very cool. Account 4 over here. Let's press next and connect. And look at that, conditionally, now we have the top header over here and we get the disconnect wallet button. And as we disconnect our wallet, now those are removed and our connect wallet button returns. Finally, we want to conditionally render the components over here as well. So let's go ahead and implement that. Visual Studio Code, So here we have our content tag, and in here we'll add that conditional rendering as well. If we are connected, we'll have what we have over in here, but otherwise, let me just go ahead and add a div with please log in, and let's format this nicely again. So if we are connected, we'll have all the cool components of the page, but otherwise we'll just have a prompt to please log in. So if we save this, now everything should be working nice. We have a please log in message over here. Let's connect our wallet. And now as we're connected with account 4 over here, we get all these components. And as we disconnect our wallet, it asks us to log in. Very, very sweet. And now the cool thing is that as we connect our wallet, we also get the address of the wallet that just connected. So what we can do is go ahead and make an Axios request to our backend to get the user's details for the Web3 PayPal smart contract. So for that, let's go ahead and import Axios, import it over in here, and we'll also need useState and useEffect from React. So these will allow us to make the Axios request every time someone connects and set some state variables. Let's set the state variables over here at the top of our app component. So adding them just over in here, we'll have a name variable, which we just initially set to 3 dots. Same thing for balance. Your US dollar balance is 3 dots as well. Your history is set to null, so we won't present it if your history hasn't come back from the backend already. And then for the request, as we have those different keys, we'll set a basic template over in here just to make sure our app works nicely. So this is very key. Have an object with a 1 key, which has an array with a 0 in it, and then a 0 key with just an empty array. Now what we can do is go ahead and create a function to get your name and balance. Async function over here, which will get name and balance, which is just the function we call here in React. And then we will go ahead and make our Axios request like so. So we make a request where we pass in as a parameter the address that we get from use account hook using WAGMI. So as long as it has connected their wallet, we should have an address when we can pass that as a parameter to our backend function that we've already seen how it works. And now what we can do is we can get the data from the response. So our response, not const r, const is what we call our variables in JavaScript, and then go ahead and get the response data like so, And if you want to see what the response looks like, we can console log it in our console log response like so. And the most important thing here is now to set our state variables. The one state variable we might not have is a name. As you know over here, when we get our name key, we have a Boolean to check whether we have a name. So we'll have to check that Boolean and only then set our name to the name in the first element of the array. Otherwise, we'll just leave it as the 3 dots. But otherwise, we can set everything to what we get as a response from the backend. So jumping into Visual Studio Code, we pass if the response name key's second element is true, then we set the name to the first element. And otherwise, we just leave it to the 3 dots over in here. And then everything else is very straightforward. We set the balance to the stringified format of the balance, the dollars to the stringified format of the dollars, history to the history, and request to the requests. And now what we can do over here as well is we can set everything back to the initial state when a user disconnects. So adding that over in here. So we set our name to the 3 dots, and we basically set all the state variables to their initial values when a user disconnects. And we can go ahead and test this out. So now as we go to Google Chrome, jump up and open up our React app. Let's go ahead and inspect. So we see our console, and then let's connect our wallet. Okay, we didn't get anything in our console, but that is because we didn't actually call the get name and balance function over here. So what we have to do is create a use effect. So every time the is connected state changes and we are actually connected, we'll call this get name and balance function. So let's write a very simple use effect over in here. Like so, use effect, which is triggered every time the is connected state changes. And if the is connected state is false, we'll just return and won't run the get name and balance function. But as long as we are connected, we will go ahead and get the name and balance, and we should get in our console the response from our backend. So let's go ahead and save this, try this again. And you see over in here, because we're using React in strict mode, it runs the use effect twice, but we get the balance, which is 5 matic for their account 4. Balance in dollars is 5.69. Our history, we have 3 transactions in our history, where the most recent one is that sending of 3 Matic for the Coca-Cola, as you see over in here, to J-Man. And then we have our name, which is Samantha, and then our requests, which we don't have any active requests currently. But now, as we disconnect our wallet, let's go ahead and disconnect MetaMask as well. Disconnect over in here and change to account 1 and connect with this wallet. Account 1 over here, press next and connect. And look at that. Now we get another response from our backend. We get the balance for this account, account 1. And as we see, our history object only has that one history object where we received 3 Matic from Samantha for the Coca-Cola. But our name is J-Man, and our request, we have that one request from Samantha over here. We have their address, the amount of Matic they're requesting, and for what, cookies and milk. So now we have everything we need to go ahead and populate all these components on our PayPal front end. So let's go ahead and do that. Let's do the easy things first. Let's go ahead and populate our dollar balance, our name, our native balance, and our table. And then finally, we'll go ahead and check out how we can call the right functions on the smart contract to request some payment and actually pay and get the number of requests we currently have to pay. So let's go ahead and do that. All right, so let's jump back into Visual Studio Code. And as we're checking out the current balance component first, let's go ahead and pass the current balance in dollars that we set. We have the dollar key that we get when we call this function. Let's set that as props over in here. So we send the current balance components, the dollars amount we get from our backend. And now, as we save that, let's jump over into our components and our current balance component. Let's make sure we get our dollars props over in here. And rather than displaying a hard-coded $121.12, let's go ahead and display our dollars amount. Dollars like so. And now that's all you have to do. Go to Google Chrome, and now you see that we have $23.53. And that's exactly what MetaMask shows us as well. $23.45, depending on the exchange rate. So now that is very cool. We can do the exact same thing for account details. So we have to have our name and our Matic balance as props to this account details component. So let's go ahead and do that in our app.js. We have our account details component over in here. Let's go ahead and add 3 props, our address that we've logged in with, the name from our smart contract, and our native balance, all stored in these state variables. Let's save those and then open up our account details over in here. Let's pass those in here, address, name, and balance. And now going over where we have our name set to Moralis Mage, hard-coded. Let's go ahead and add name over in here. Then for our address, you see we have this nice format where we have the first 4 digits, then 3 dots, and then the last 4 digits. So we can add a little bit of nice slice magic to get this effect. So let me just paste it over in here. So from our address, we slice the first 4 digits, then add 3 dots, and then slice the last 4 digits like so. And then finally, our native balance in over here where we've set to 132. Let's go ahead and just get our balance state variable and paste that in over here. Save that. And now as we open up Google Chrome, look at that. We have J-Man, the name we set on our smart contract. We've got that with Moralis, sent it over from our backend to our front end. And now we also have our native Matic tokens using Moralis endpoints. How sweet is that? And now finally, let's do it for our history of activities. This is very, very simple stuff. Let's go ahead and jump into Visual Studio Code. Our app.js, we have the recent activity component over here in our second column. And what we'll do is get the history variable, state variable, pass in as a prop to our recent activity component. And here in our recent activity, you see we've hard-coded this large history array. What we can do is we can remove this like so. We've already set the columns array to format our table very nicely. So all we have to do is pass the history object over in here. And as we formatted the history very nicely, over here you'll see history is an array of objects. So currently we only have 1 row of data, but as we get more activity, we'll get more rows. So jumping back into Visual Studio Code, as we pass history over to here, it will use that history variable, state variable, as the data source in our table. As we save that, now we open up Google Chrome and our React app. Look at that. Samantha has sent us. So we received from Samantha 3-matic for the Coca-Cola we requested. And now the coolest thing is it's all interactive. So as we disconnect our wallet, let's go ahead and disconnect MetaMask as well. Disconnect. Jump over to account 4 over here, where we know is Samantha's account, and they have at least 3 activities. Let's connect this wallet. Press next, connect. And as it's connecting, now we get Samantha's details over here. Account 4, 5-matic. Over here, you see 5-matic. You get the name Samantha on the Web3 smart contract. You get their dollar balance, and you get all their recent transactions. They sent Bob the Builder some matic for bricks. They received some matic for movie snacks from Bob the Builder, and to J-Man, they sent 3 matic for the Coca-Cola. This is very, very sweet. Now, the final thing to do is actually call these smart contract functions on our Web3 PayPal smart contract to pay for any open requests and then go ahead and request new payments. So let's go ahead and implement that finally. Let's jump back into Visual Studio Code. Rightio, so now we've got the 3 components out of the way, and now moving on to the final, most interesting component. First of all, in app.js, of course, request and pay have to get 2 variables as props. One will be the requests object, requests equals requests, like so, and then we'll also pass the get name and balance function, as when a user makes a payment, we want to make a new call to the backend to get the latest transactions and remove any request that we've already paid from our requests object. So let's go ahead and get name and balance. Let's pass that as a prop as well. Get name and balance, like so. Save that. And now jumping back into request and pay, let's make sure we pass those here as props to our component request, and then get name and balance function. Now, first of all, what we can do is, as you see in our app over here, we have this nice little red dot over here indicating how many open requests we have. And if we look at this account, open up our console, this account will have 0 requests. But as we disconnect our wallet, change our account, disconnect this account, and go to account 1 over here, as we connect this wallet, like so, check out that over here in our requests, what we have is we have 1 request. So we see the length of each of these keys is 1. So this is the one that we want to present over in here. So let's go ahead and implement that. Jump into Google Visual Studio Code, and as we have our requests object, we can get the length of any of the keys within it. So let's go ahead and find where we have our dollar outlined over here. And here we've just hard-coded our number of requests to be 2. But let's go ahead and make this a conditional. So we have our request object, and if the first key in the request object has a length of over 0, we're going to add the red dot, which is this num of requests div over here, and we're going to put the length of the array that is stored in key 0. So let's go ahead and save that, and now we should have a 1 appear over in here. How sweet is that? So what we can then do is go ahead and start figuring out how we can pay a open request. So let's go over to the top. We'll have to bring some things over from WAGMI again. Let's bring them in like so. So we're going to prepare contract write. We're going to contract write and wait for transaction. So after we know that a transaction is through, we're going to go ahead and call our get name and balance backend function again to get the updated status of our account on the PayPal smart contract. But then, of course, we're going to use the Polygon Mumbai chain as well, so we know we're interacting with the correct blockchain and smart contracts on the correct blockchain. Then, to be able to interact with the smart contract, we need the application binary interface, and I provided it over here in the abi.json file in the front end directory as well. So we can go ahead and bring it in, simply call it ABI, like so. So we have our ABI variable over in here that we can pass when we're using these hooks from the WildMe Web3 library. So if we take a closer look at the component, we already have some state variables that open up modals for paying and requesting for payment. And for the request, we have some state variables where we can set the amount we want to request, the address we want to request from, and the message we want to send alongside the request. But for paying a request, we only need to use our request object and decipher who is requesting and how much. So what we'll do is we'll create a use prepare contract write hook. And let me go ahead and just paste it over in here so we can talk through it. So this use prepare contract write automatically prepares a contract write for us. And this config, and we destruct this config object, we can then pass to the contract write hook, which will actually then perform the contract write. So for the chain ID, we're using Polygon Mumbai. Then we have to pass our own smart contract. So this is our Web3 PayPal smart contract. Use your own smart contract. Then the application binary interface, we just brought that in. And then the function name, we're paying the request. So you can check that out over in here. Pay request is the function name. And already we can check out, takes only one parameter, the request ID. So how many requests the user has, we have to take the request ID. We'll always take the first one, so the 0th element in the array of requests, and the payable amount, which will be the value sent alongside the contract interaction. So that's also set in the request object. So here, as we jump into Visual Studio Code, we can see that the argument that we pass is just one, the request ID we want to pay. So we'll always pay the first request we have in our list, and in the overrides we pass the value which we can get from the requests object, the number one key, and we'll always get the first element in the array, and we of course multiply by the amount of decimals that the Matic currency has, which is 18. So just to make sure we know where this is coming from, if we open up Google Chrome, open up our console, over here in our object we see the requests. We're looking at the object with the name 1 and always the first element. So here we see we're asking for 5 Matics for cookies and milk. So that is what we're sending as the value. Now, after we have use prepare contract write set up, we can go ahead and use the use contract write hook with the config object we got from over here, use prepare contract write. And this gives us a function to write on this smart contract with these details and the current data of that contract write. So this we can use then with use wait for transaction to wait for when that contract has gone through, and then we can fire again our get name and balance function. It's a bit of a mouthful, but I'm sure you'll follow very soon. So what we can do over here is we can create the use wait for transaction where we get the is success object, and in here we only have to pass the hash of the data of the contract write. So every time the is success state changes, we're gonna go ahead and rerun our get name and balance function. So we can do that over here straight away by creating a use effect like so. So if the is success state changes and we get a is success true, we go ahead and rerun our get name and balance. So then our request should reduce by 1 and we won't have to pay a request twice. So all that's left to do is go ahead and add this write function as an on-click event to our pay button. So at the bottom over here, we have our pay button like so. So we have our pay button, and when we press it, it calls the show pay modal function, which opens up our modal. So confirm payment, open modal over here. What we have to do, that on OK, will hide the pay modal, and we'll also go ahead and use the write function, just making sure it is available like so. But one thing we can do here in the confirm payment modal, we can actually decipher from our request object what we're actually paying. So what we can do is create a very small conditional over here that as long as we have a requests object and the length of the 0 key in the request object is greater than 0, we'll go ahead and apply a heading with sending payment to the name of who we're sending it to, the value we're going to send, and then at the bottom we'll have the message that's associated to that payment. So let's go ahead and save that, and let's go ahead and see what this looks like now. So opening up Google Chrome over here, what we can do is we have this one payment to pay. We can go ahead and press pay. This opens up a modal for us to confirm payment. We're sending payment to Samantha for a value of 5 Matic, and the message is cookies and milk. I remember I had to pay Samantha 5 Matic for cookies and milk. Let's proceed to pay. And now MetaMask opens, asks us, do we want to send 5 Matic to our Web3 PayPal smart contract, which will then send it to Samantha. Let's go ahead and confirm this. And now, after it's confirmed, we should get an update over here in our React front end. We don't have any request to pay anymore, and we've just sent Samantha 5 Matic for cookies and milk, and our balance has gone down. And as we disconnect our wallet, let's go check out Samantha's account. Let's disconnect our wallet, jump over to Samantha's account over here, connect our wallet. Next, connect, and it's fetching the data from our backend. And look at this. Now Samantha has 10 Matic from the original 5 Matic. That's $11 in dollar amounts. And then J-Man we have just received from J-Man 5 Matic for the cookies and milk we requested. How sweet is that? So now final thing to do is go ahead and create the request functionality. So as we set the amount we want to request, who are we requesting it from, and the message associated to the request, after pressing the proceed to request button, we will create a request on the smart contract. So let's go ahead and implement that last. Opening up Visual Studio Code. And as we scroll up here, above our use effect, what we'll essentially do is these 3 steps, but for the send request function on our smart contract, over here, create request. So let's go ahead and jump into Visual Studio Code and add this use prepare contract right. And this time the config object will call config request. And we're doing the exact same thing for Polygon Mumbai to our smart contract, our ABI. Our function name is create request. And this time it takes 3 arguments, which is the request address we have in a state variable that is set with a @design input, then the request amount, same thing, and the request message. So what the user inputs in these state variables will be sent to the smart contract as the request details. Then what we do is do this contract write bit over here. So just pasting that over in here, we use the contract write hook with this config request object we created over in here, and we get a function to write a request and then the data to check when the transaction has successfully gone through. So finally is just checking for this is success state, like so, is success, and we're checking that the data from this write function has gone through, and we can actually implement them over in here. So as long as is success request or is success changes to a true state, we're gonna go ahead and rerun our get name and balance function. Let's pass it in as a trigger to this as well. And that's as simple as it was. So now as we go to Google Chrome over here, let's open up our React app. So now our request should be functioning. Now let's go ahead and try and send, we've been sending requests and payments between J-Man and Samantha over here. So let's send some to Bob Builder over here. Let's just make sure that they have some Matic to send. So over here, we have account 5 over here. This should be Bob Builder's account, copy that, and they have 5 Matic, so we can go ahead and do that. Let's send a request for, say, 1 Matic to this address, which is Bob the Builder's address, and what we're going to go ahead and say, this is for a lemonade. I'm lacking creativity with what these payments are for, but lemonade, we're asking from Bob the Builder. Let's proceed to request, but now MetaMask didn't pop up because we actually didn't go ahead and write this function, write request anywhere. So what we have to do is take this and make sure we call it in our other modal over here. So on OK of our requested payment, what we have to do is go ahead and write request as long as we have it like so. So now it should go ahead and function properly. So let's go ahead and do it again. Request from Bob the Builder for lemonade, 1 Matic, proceed to request. MetaMask pops up. We're sending this to our smart contract. Let's confirm. And this should now go through. Let's go ahead and disconnect our wallet. Let's go ahead and disconnect MetaMask as well. Account 4 over here. Make sure we're disconnected. Jump into account 5. Connect our wallet. Next, connect. And let's go see. We have 1 request over in here. All our previous requests were with Samantha. But now as we go ahead and pay, what is Samantha asking for? Sending payment to Samantha, 1 Matic for lemonade. I do remember this. I go ahead and proceed to payment. Let's go ahead and just confirm this. And now as it goes through, we should get a update over here in our front end with this one going away and a new row being added over here, 1 Matic lemonade to Samantha has just been sent. Very, very beautiful. And we can just do a final check that Samantha actually received the money for the lemonade. So disconnect our account, go over to account 4 over here, connect our wallet. And I already saw that Samantha had 11 Matic. So they've received the 1 Matic, 11 Matic should pop up over here. And now they have $12 worth of Matic in their wallet. And Baba Builder just sent them 1 Matic. This is awesome, awesome, awesome. So now we've built a smart contract with Solidity, we've deployed it and verified it with Hardhat, and then we've created a front end where we interact with the smart contract with the Moralis Web3 API, and then we send those details to our React front end, and we have this very cool interface for a Web3 decentralized PayPal. I really hope you enjoyed this blueprint and you check out the future blueprints and previous blueprints as well, and let us know in the comments what you'd like to see next. I'll catch you in the next one.